Welcome to another deep dive. Are you ready to explore something fascinating with me?
I'm always up for a deep dive. What are we looking into today?
Today, we're taking a look at something called Podometic.
Podometic, okay.
Yeah. It's this system developed by an Australian math historian named Jonathan J. Crabtree, and it might completely revolutionize how we teach and learn arithmetic.
Sounds like a tall order, but I'm intrigued.
Right.
What's so revolutionary about it?
Well, Crabtree actually argues that the traditional methods we're using to teach things like multiplication and exponentiation, they have like a fundamental flaw, like a logic virus almost.
A logic virus. That's an interesting way to put it.
I know, right?
How could something as basic as multiplication be flawed, though?
So Crabtree calls this the Billingsley virus.
Billingsley virus.
Yeah. BV1570.
What? What is that?
Okay, so it goes all the way back to 1570, and this guy, Henry Billingsley, who translated Euclid's Elements.
Okay, Euclid's Elements, a classic.
Exactly. But in his translation, Billingsley defined multiplication as A added to itself B times.
A added to itself B times. I see where this is going.
Yeah, it seems straightforward at first, but it leads to these inconsistencies, especially when you bring in the numbers 0 and 1.
Right, because if you multiply 1 by 1, you get 1.
Exactly. But with Billingsley's definition, you would end up adding 1 to itself once. So 1 plus 1 equals 2.
Ah, I see. So the definition breaks down right there.
Exactly. And it's not just with 1. Any number multiplied by 0 should be 0, but with that old definition, it would just stay the same.
It seems like that would create a lot of confusion, especially for young learners just starting out with math.
And Crabtree thinks that this all goes back to the time when 0 and 1 weren't really considered numbers yet.
Fascinating how such a simple definition can have such far-reaching consequences.
I know. Makes you wonder if we might be teaching other things wrong too, right?
Absolutely. But that's what makes this deep dive so interesting. We get to question everything we thought we knew.
Exactly. So, now enters Podometic.
Podometic. Okay, I'm all ears.
So Podometic tackles this problem head-on and uses 0 and 1 as its base.
Interesting. Okay, so how does it work?
It redefines multiplication as adding A to 0 B times.
Adding A to 0 B times?
Yeah, like 2 multiplied by 3 would become 0 plus 2 plus 2 plus 2.
Which is 6. Okay, that makes sense.
Right. It's a simple change, but it just clicks.
It does seem more intuitive, I have to admit. What about exponentiation? How does Podometic handle that?
Oh, that's pretty cool. Podometic defines exponentiation as multiplying 1 by A B times.
Multiplying 1 by A B times.
Yeah. So like 2 to the power 3 would be 1 times 2 times 2 times 2, which is 8.
It sounds like this system could be much easier for children to grasp, especially at those early stages of learning.
Right. It just removes all that confusion and all those weird exceptions that come up with the traditional method.
It's all about building those foundational concepts in a way that makes sense.
Exactly. But it doesn't just stop there. Podometic also tackles another big problem area.
Oh, what's that?
Negative numbers.
Ah, yes, negative numbers. Always a bit of a head scratcher, those.
Right. So tell me how Podometic would handle, say, multiplying a positive number by a negative number.
Okay, so with Podometic, multiplying by a negative number just means subtracting from 0 repeatedly instead of adding.
Oh, that's interesting. So instead of memorizing different rules for positive and negative numbers, it's all just about adding to or subtracting from 0.
Exactly. The principle stays consistent.
Okay, I'm starting to see the appeal of this system. What about exponents with negative numbers?
For those, Podometic uses repeated division from 1. So 2 to the power of negative 3 would be 1 divided by 2 divided by 2 divided by 2.
Which is 1/8. Wow.
It really does seem like Podometic offers a more streamlined approach to these concepts. It addresses some of those fundamental inconsistencies we've been talking about.
It does. It's like it's laying a whole new foundation for mathematical understanding.
Exactly. And that's what's so exciting about it. What if this isn't just about fixing a few basic operations, but about understanding math in a whole new light?
You're blowing my mind right now. What if it is?
It really makes you think. And it goes even further. This Podometic, it could change how we think about some advanced mathematical concepts, too.
Like what kind of concepts?
Well, for instance, let's take the concept of 0 to the power of 0.
Oh, yeah, 0 to the power of 0. I remember struggling with that one back in my calculus days.
It always felt like a bit of a fuzzy area in traditional math, right?
Exactly. It just never felt quite right.
Yeah. And you often see it treated as undefined or indeterminate, which leads to all sorts of complicated workarounds.
Totally. It always seemed like a cop-out to me.
Right. But with Podometic, 0 to the power of 0 is simply 1.
1, just like that.
Yep. It fits perfectly with the system's definition of exponentiation as repeated multiplication from 1. So you start with 1 and multiply it by 0 times.
It's amazing how such a seemingly small change can have such a big impact on something that always felt so complex.
Exactly. And who knows? This shift in thinking could have ripple effects throughout higher levels of math, maybe even lead to simpler, more intuitive solutions to some really tough problems.
It's like Podometic is providing a whole new lens to view math through. From basic operations to these really advanced concepts.
Exactly. And this potential for a widespread impact is what makes Podometic so fascinating. It really makes you wonder, could this be one of those rare black swan events?
Black swan events. Remind me what those are again.
A black swan event, the term was popularized by Nassim Nicholas Taleb, is like this unpredictable event that has a massive impact, something that often seems obvious in hindsight but catches everyone off guard.
Okay, yeah, I remember those. So how could Podometic be a black swan event?
Well, for one thing, it's definitely challenging a system that has been in place for centuries.
If it really does lead to a fundamental change in how we understand and teach math, the impact could be enormous.
Oh, absolutely. Just imagine it. Rewriting textbooks, changing the way teachers are trained, even revamping standardized testing. It would be a huge undertaking.
Yeah, it's a little daunting when you think about the scale of it, but it's also really exciting.
Oh, for sure. Especially if Podometic can help create a generation of students who are more confident and comfortable with math.
Can you imagine a world where math anxiety is a thing of the past? Where kids actually look forward to math class?
It's a beautiful thought, isn't it? And beyond the individual benefits, think about what a more mathematically literate population could mean for society as a whole.
It could lead to huge advancements in so many fields. Science, technology, engineering, the possibilities are endless.
Exactly. And it all stems from this one seemingly simple change in how we approach basic operations. It's incredible.
It really underscores how important it is to question everything, even things that we've always taken for granted.
Crabtree's work is a perfect example of that. It shows that innovation can come from unexpected places, and that we should always be open to new ways of thinking and learning.
Well said. But let's be realistic for a minute. Implementing a change like this on such a large scale, it can't be easy.
No, of course not. There would definitely be challenges.
Like what?
Well, as we've already touched on, the scope of the change itself would be massive. You'd need to rewrite all the textbooks, retrain teachers, and figure out how to adapt standardized tests. It would require a huge coordinated effort from everyone involved in education.
And let's face it, people don't always embrace change, especially when it comes to something as fundamental as math. There's bound to be some resistance.
Oh, absolutely. There will always be people who are more comfortable sticking with what they know. Overcoming that inertia is a major challenge. But that's where clear communication and education come in.
Right, we need to do a good job of explaining the benefits of Podometic and address any concerns people might have.
Exactly. We need to make sure people understand that this isn't about throwing out traditional math altogether. It's about building on what we already know and finding better, more effective ways to teach and learn.
It's about evolution, not revolution.
Exactly. And framing it as a natural progression, a way to improve what we already have, could be key to getting more people on board.
It's a powerful message. Podometic is not about tearing down the old, but about building something new and better on a more solid foundation.
Exactly. So where does Jonathan Crabtree himself see this going?
Yeah. What's his vision for the future of Podometic?
Well, Crabtree sees Podometic as a catalyst for real change in math education around the world. He imagines a future where math is no longer this scary, frustrating subject, but something that sparks curiosity and joy in learners of all ages.
I love that.
He believes that Podometic has the potential to truly democratize math, make it accessible to everyone regardless of their background.
That's a really inspiring vision, a world where everyone can embrace and enjoy math.
It is. But of course, achieving that kind of vision takes more than just a new system. It requires a shift in mindset, a willingness to embrace change and challenge those old ways of thinking.
It's about fostering that love of learning, encouraging critical thinking, and recognizing that math is about so much more than just memorizing formulas and passing tests.
Exactly. It's about understanding the world around us, solving problems, and creating new possibilities. And maybe, just maybe, Crabtree's Podometic is the spark that will ignite that change.
It's a call to action for anyone who believes in the power of education to transform lives.
Couldn't have said it better myself. This has been a really thought-provoking discussion. Before we wrap things up, is there anything else you'd like to share with our listeners about Jonathan Crabtree and his work?
Well, Crabtree's story is pretty inspiring, actually. He first noticed those inconsistencies in traditional multiplication when he was just 7 years old.
7 years old.
I know. And he's been working on Podometic, refining it and sharing it with the world for years.
It's amazing what a curious mind can achieve. It really shows that anyone can make a difference, no matter their age or background. Exactly. And speaking of making a difference, I know some of our listeners are probably wondering how they can learn more about Podometic.
Yeah, where can people go to find out more about this system?
Well, Crabtree has a ton of resources online. He has a whole website dedicated to Podometic.
Perfect. And I'm guessing it's got all the details, maybe some examples, tools for people to try it out.
Oh, yeah, all of that. He's really passionate about making Podometic accessible to everyone. And he's also published a bunch of work, including this peer-reviewed paper. It's called The Lost Logic of Elementary Mathematics and the Haberdasher Who Kidnapped Kaizen.
Okay. The Lost Logic of Elementary Mathematics and the Haberdasher Who Kidnapped Kaizen. That's a mouthful.
It is.
But it sounds fascinating.
Oh, it is. He really delves into the history and the mathematical foundation behind his work in that paper. It's a great read.
Awesome. We'll definitely make sure to include links to his website and that paper in the show notes for everyone. Well, it's been incredible exploring this whole world of Podometic. It's really got me thinking about how we teach math and how we can make it more intuitive and engaging for everyone.
Me too. Podometic is definitely pushing the boundaries, challenging us to rethink those traditional methods and explore new possibilities. Whether it becomes the standard way of teaching or not, the conversations it's sparking are incredibly valuable.
Yeah, it's a reminder that even in a field like mathematics, which can seem so set in stone, there's always room for innovation and improvement.
Exactly.
Well, that brings us to the end of another deep dive. A huge thank you to all of you listening for joining us on this journey into the world of Podometic.
It's been a pleasure.
We hope you learned something new and maybe even feel inspired to explore Podometic a bit further on your own.
And remember, never stop questioning, keep those minds curious, and keep exploring the amazing world of knowledge.
That's right. We'll catch you on the next deep dive.